Questions 51 and 53 are asking us to simplify rational expressions. Let's take a look at this first one here. What we want to always do is look for common factors. No matter if you see an x squared or an x to the third or m to the third, always look for common factors first and pull those common factors out. So I see 5m to the second power goes into each of these terms. So that's what I'm going to take out from each. And so I've got now a 5m squared on the outside. Leaves me with an m plus 2 inside some parentheses. Take out any common factors you can, but here we cannot. So if you can't, and it's an x squared or an m squared in this case, a quadratic, look to see if it will factor as two binomials. And it does. M plus 2 and m plus 1 is the way it factors. And so now we can go ahead and cancel out these m plus 2's, and we've got an m, or a 5m to the second, all over an m plus 1. And that would be our answer. Same thing here, look for the common factors always. So that's the key. So some people will think, oh, I'm supposed to have two binomials because it's x squared. No, it's not the case every time. Always look for the common factors first. Sometimes it's just a binomial and a monomial. And so we go ahead and factor the denominator. It does factor as an x minus 1 and x plus 3. And because we needed more positives than negatives to add or subtract to make the 2x. Well, the x minus 2's end up canceling, leaving us with an x over x plus 3. Now, don't cancel out the x's, because it's not really x on the bottom. It's 3 more than x. Taking a look at the next one, we want to look for common factors, but I don't see any up top. So it just factors as two binomials. Start with the prime number, 1 and 3, multiply to make 3. Now, you know they subtract. The outside-inside terms subtract to make 4. So you think, okay, I don't want 3 to multiply by 4 because that'll make 12. So try 2x and 2x. You see, that'll make 6x minus 2x will make 4x. To make it a negative 6 or a negative 4, let's make this 6 negative, so 2 times negative 3, and the 2 positive. Down below, it's a difference of squares. So any binomial that factors as two binomials will always be a difference of squares. And this will factor to 2x and 3, so 2x minus 3 and 2x plus 3. That would be our answer. Well, we go ahead and take out that common factor. We got a 2x minus 3 cancels out. Leaves us with this 2x plus 1 all over a 2x plus 3. Again, people want to cancel out those 2x's, but you can't do that because it's not really 2x on top. It's 1 more than 2x. It's not 2x on the bottom, it's 3 more than 2x. This one's a little bit tricky. There's a common factor first of 2, so you take out that 2, and you got an x minus 7 left over. Down below, you see how the 49, the constants first, then the variable term, and the variable is negative. So you want to take out a negative 1 first. To pull out the negative 1, and then it's going to switch the signs. Now it's an x squared, and it's a minus 49. I switched the terms around as well. So now try factoring that. So we got the 2, x minus 7, and then the negative 1 on the outside. And since it's a binomial and it's a difference of squares, it factors as two binomials, x minus 7 and x plus 7. And so now we can go ahead and take out that common factor of x minus 7. Those will be gone. And typically you're going to divide the negative 1 into 2, so you typically write it as, or see it as, negative 2 over an x plus 7 if it were on a test. Well, looking at the next one, no common factors, but it's two trinomials. And so they do factor as two binomials, x plus 7 and actually a t this time, t plus 7 and a t minus 3. And so down below you've got another trinomial. It factors to two binomials. They're both minus signs because they multiply to make a positive 6, and they add to make negative 5. So now we can go ahead and take out that common factor, t minus 3. Those will disappear. So you're left with a t plus 7 all over a t minus 2. And that is our answer. So let's take a look at our next problem here. Here we're going to multiply two rational expressions, so always take out common factors first. So I see that this has a 3 and an x. So I'm going to take out a 3x. Put that on the outside of a parenthesis, do some division, and you've got an x minus 3 left over. And then on this next one, so continue on the top of the fraction. And so it's a trinomial. It factors down to an x plus 4 and an x plus 3. And then we look down here, we've got a difference of squares. It's going to factor to an x minus 4 and an x plus 4. And then the next one's going to end up being another difference of squares, x minus 3, x plus 3. Now just take out those common factors. So you see how the x minus 3's, those will disappear, x plus 3's, x plus 4's, and so all we have left is that 3x on top, and down below an x minus 4. That would be our answer. Well, same thing. Look for the common factors. 4x is the common factor there, so you pull out that 4x, put it on the outside of a parenthesis, do the division, you got an x plus 2. That's the difference of squares on top. X minus 4, x plus 4 is the way it factors. And again, you got to factor in order to cancel. Nothing will cancel. Like the x squareds don't cancel. You can't cancel out an 8x and 14x squared. You've got to factor in order to cancel when you've got addition signs between terms. So the next one's going to, down below, factor to an x plus 3 and an x plus 4. And here we have a common factor of 7x to the second. So pull that 7x to the second on the outside, and then do the division, you got an x plus 2. And so now we can start looking for some common factors. So I end up seeing the x, let's see, plus 2's, those will cancel. I see an x plus 4 canceling, and I see this x down here, or up top, will cancel out just one of the x's down below. And so that's how I'm getting this 4, and then times by an x minus 4 on top. Down below, I've got a 7x, and I also have the x plus 3. So that would be our answer. Looking at the next one, it's a division problem. So remember, you're going to take the reciprocal as you do this problem. So when I look at this, I've got x squared minus 9. That's going to factor to an x minus 3 and an x plus 3. And then when I do the top of the next part of the fraction, it's this portion that I'm going to put on top. So I factor that, 2x, and we'll try to get, let's see, an x, and then I need to make a 7. So I'm going to put a 3 here, make that negative, and a 1 here, make that negative as well. They had to be the same sign because they multiply to make a positive 3. And so down below, I've got an x minus 3 and an x plus 2. And then I've also got a difference of squares here, but there's a common factor of 4. So pull that 4 on the outside, and when you factor it, it factors down to x squared minus 9 is what we get. So you see, that's another difference of squares. So when I go ahead and factor that, I end up with an x minus 3 and an x plus 3. So I can now go ahead and cancel some terms out. So I see the x minus 3's will now cancel. I've got, let's see, an x plus 3 canceling. I got another x minus 3. But that's as far as I can go. So I've got the 2x minus 1 on top. It looks like I've got this 4 multiplied by an x plus 2 on the bottom of the fraction. And that would be our answer. So let's take a look at our next one here. Another division problem. Again, make sure that you take the reciprocal as you're doing these. So take out the common factor first. 2 is the number. Goes on the outside of the parenthesis. X minus 2 is what we've got there. Here we've got a common factor of x. So notice a lot of people want to do two binomials, but it doesn't factor that way. And so if you got the common factor, always take that out. X is a common factor. We've got an x plus 5. Here we've got a common factor of x squared. So put the x squared on the outside, and then you got an x minus 1. Some people will forget that minus 1. If everything cancels, always put a 1 with what we have left over. So down below, we've got this trinomial. It's going to be an x minus 2 and an x plus 5. So we're ready to start canceling. So let's go ahead and do that. X minus 2's are now gone. X plus 5's. It looks like this 1x will disappear, but take out only one of the x's down below. So what's left over? We've got a 2 on the top. We've got an x times by an x minus 1 on the bottom of the fraction. That is our answer. Well, looking at the next one, it's a add and subtract for 56 and 57. So notice that denominators look the same, but they're not. They're not, because you see this one has a negative 2 and a positive 2, but the x's are the same. So you got to multiply by the other's divisors, which you're going to end up doing. So you multiply by an x minus 2 over x minus 2 on the right-hand side. Left side needs an x plus 2 over an x plus 2. So when you do this, you've got to distribute. Distribute this x plus 2 over the 3. So it's 3x plus 6. And then just write this as one fraction at this stage. Distribute the 5 over that x minus 2. So it's positive 5x minus a 10. Down below you've got the x plus 2 and the x minus 2. A lot of people want to factor. But if you factor, you get right back to where you started. So don't do that. Just collect like terms. So we got this 8x minus 4, and then all over this x plus 2, x minus 2. And if you do take out the common factor of the 4, it doesn't cancel anything out, so there's no need to worry about that. That would be our answer. So down here, this side needs an extra x. That's what it's missing. This one has 2 x's here. This one just needs a 2. And so you go ahead and multiply. You got 6 over 4x squared. And then we're adding, watch the signs, watch the numbers here. X times x makes x squared, and then x times 2 makes 2x. Down below, you got the 4x squared. So I could have written it as one big fraction. That's what I'll do next. X squared plus 2x plus 6. You could try to factor it, but it doesn't factor. So you can't take anything out, so that's our answer. Next one, a subtraction problem. When you see it, change it to addition right away. And then look for that common factor on the bottom. Don't see any, so you just multiply by the other's denominator. This side needs a 2. And so go ahead and write as one fraction now. 8 minus, and then watch the signs there. Minus because it's a negative x times x makes a negative x squared. Negative x times negative 1 makes a positive x, 1x. Down below, it's just 2 times by x minus 1. And so all I would do is just write it in descending order. Negative x squared plus x, and then plus 8. Down below, you've got that 2 times by x minus 1. That is our answer. Last one here. Again, look for that common factor, but you don't see it. So change it to an addition problem right away. Multiply this side by x plus 1 over x plus 1. This side needs an x minus 1 over an x minus 1. So we go ahead and do some distributive property here. So 3x minus 3. Over here, do the same thing. Negative 4x and a negative 4. And then down below, you got that same factor. X minus 1, x plus 1. So you can go ahead and collect some like terms there. Watch the signs. We've got opposite signs here with the 3x and the negative 4x are making a negative x. And we got that negative 3 and the negative 4 combined together to make negative 7. Down below, you got the x minus 1 and the x plus 1. And that's as far as I'd take the problem. So no canceling, so we'll just leave it like that. Well, those are some of the problems that you'll see. Questions 51 through 57. Check more problems.